This conference will now be recorded.
Okay. Okay, so let's get started. I'm going to put the session on record and let's jump into our Cloudera distribution here. So I guess in our yesterday's class, we started off a discussion about big data. We spoke about a lot of components of big data. We also spoke about a lot of, the HDFS commands, right? So we spoke about what is HDFS, what does he got to do, how is he distributing. Then we spoke about a lot of HDFS commands on how do you probably, list all the files available, how do you push files, how do you get files, how do you move them, how do you copy them, how do you make directories, right? How do you print the files there? So I guess we've pretty much spoken a lot about HDFS. I'm thinking that you guys should be okay with it. Now with this, what we're going to do right now is, guys, we'll jump into Hive. Okay, so we in fact started off with an example yesterday, right? Hive. So let's jump into Hive. So I'm going to open up terminal. So we have been opening it, we have been working on this one in terminal only, right? All the things. So we'll just keep it in terminal. So like just like what we did yesterday, let's go back to Hive. Let's try to list all the databases available. Let's try to delete, if there's any previous tables, and let's try to create some tables, okay? And then we can probably go on and we can discuss about how is Hive really handling unstructured data, or probably I would probably even call it as a semi-structured data. How is he probably handling it? Okay. So what we have just done is we said Hive and we hit enter. He's opening something called as Hive command line interface. It's basically your CLI, right? So the first question we're going to ask is, hey, can you please show me the databases? So what are the databases available now? He's saying there is one thing, something called default, another database, something called test. You can go back and ask him to use anything that you want. Okay, I'm going to leave it to the default. So he has chosen the default. Now we'll go back and ask him, hey, can you please show the tables? Looks like there are a couple of tables available here, right? So we can just go back and say, hey, drop table something called acad. Similarly, can you please just go back and drop a table something called employee? Okay, so we'll just go back and say, hey, can you please, go back and drop even this particular table? So we'll just drop them, clear the screen, ask for show tables. Looks like there are no tables available. So it's completely fresh. We need to start adding tables to this particular Hive database now. So what did we do yesterday? We said create table. What was the table name? The table name was something called employee. We are opening bracket and we are saying, hey, I want you to create a column something called ID, which is going to be of integer type. I want you to create a column called name, which is going to be a string type. Okay, by the way, I'm assuming that the screen is visible, guys. Okay. So we're going back and saying, hey, I think it is. Okay. So we are saying ID, which is of an integer type, and name, which is of a string type. We can hit enter. Then we are saying that the data that I'm going to push for you is going to be row format, delimited. Here, the fields are basically terminated by, let's say, a piping symbol if we were to use that. And now we are saying, I want you to store this particular table as one of the formats, something called as a text file format. Okay, so there are four formats by which the Hive can save its tables at the backend. So there's something called text file, sequence file, OCR, Parquet, etc. So here we're just saying, I want you to save it as a text file. We can just hit enter. If everything goes good, he should say that the query has got executed successfully. And he's saying, okay, the time taken was probably 1 second here. Now what we will do is, guys, so let's go back and ask, where is the present working directory? We'll go to desktop, okay? And for today's class, we will create all the files within a particular directory. I'll probably call it as day 2. Okay. So, I'll just call it as second or something like that. Second day. What? Class 2. Okay. So we'll hit enter, give ls. He's going to display this particular folder called class 2. We'll just cd, that is, we're going to change our directory to this class 2 right now. You can ask for ls. Looks like there are no files available on the inside right now. Okay. So this is your Hive, guys. This is where we are in Hive, but this is your local. Okay. This is basically your local here. So now we can just go back and say, hey, gedit, I want you to create a file, something called employee.txt. Let's hit enter. So gedit is basically the editor's name and employee.txt is the file name. Okay. So we're saying, hey, this is the file name and this is the editor that I want you to probably use right now. Now we can go back and say, hey, it's the person number 1 whose name is John, person number 2 whose name is Jill, person number 3 whose name is, let's say, Andrew, person number 4 whose name is probably, let's say, I don't know, Tom. Okay, 5 whose name is probably Tim. So once you've created the file, you just have to save it. You can close it. Okay. After you've closed it, when you ask for ls, you can see that he's displaying the employee.txt file that we've just created, right? What I'll also do is, guys, I'll push a copy of this particular guy into HDFS2. So HDFS, DFS, ls, we'll basically go back and ask what are the different directories available. So there are a lot of directories, okay? Now we will say, can you please make a directory called class 2? So we will just say, make a directory called class 2. And now what we're going to do is, we're going to say, HDFS DFS, I want you to put this particular file. What is that particular file? The file is in home, Cloudera, desktop, class 2. Okay. And the file name is something called employee.txt. Where do you want me to put? I want you to put inside a particular folder called class 2 even here. Okay, even in the HDFS, you have created a folder called class 2. We want them to put this particular file inside that folder here. Now go back and ask, hey, what do you think is probably available within class 2 of your HDFS? He's going to tell you that, yeah, yes, the employee.txt file that you've created is available over here. It has just got created, 4:46 a.m. or something. Okay. So now what we will do is, guys, we can just go back here. When you say show tables, the Hive is showing the table for you, right? We'll say select star from employee. He's going to list all the records available, which in our case is right now empty because we still haven't loaded any data, right? So now we can go ahead and say, hey, can you please load data coming from, if it's HDFS, I'll just say in path. I'll say it's in the path. In which path is it? It's available in something called class 2. Okay, it's available in this particular path. And the file name is called employee.txt. So you want me to load the data in this particular path where? I want you to load it into a file name, or let's say a table name, something called employee here. So we're saying the table name itself is something called as employee. I want you to load this data inside this guy here. Okay. So load data in path into table employee, into table employee. We'll just hit enter. He's saying loading the data to the table, something called default.employee, where default is your, database. Employee is a table. Now go back and ask for select star from employees. He's saying these are the 5 records which we have just uploaded. Similarly, if it's probably coming from local, you just have to add a local keyword at the front. So you're saying what? If it's going to come from local and probably not from HDFS, you need to add a local keyword here. Now we will go back and say, hey, in home, there is a folder called Cloudera. Within that, there is a folder called desktop. In desktop class 2, employee.txt. Let's go back and hit enter. So from the local file, he's pushing data into the employee. Go back and ask for select star of employee. You can see first 5 records from HDFS, the second 5 records from what? From your local file right now. So this is exactly how, you know, you can probably load data inside your table. I'll also give you another method, okay, another common method. I'm not very sure what is the technical name for it, but typically from a table to table, right? We typically call a staging table, if I'm not wrong. So from a table to table, we'll try to push data right now, okay? Now see you guys, we'll go back and create a table, something called employee 2. I'll call it as employee 2 because it's the same version of the table, but I'll call it as employee 2. There's one column called ID, which is integer type, one column called name, which is string type. Let's hit enter. It is row format delimited, where the fields are terminated by, let's say, this colon. Okay. And now what we're going to do is you're saying, hey, I want you to store this particular table in a particular fashion. Let's call it as a sequence file. Okay, there's a format, something called sequence file. Basically, it's a compression compared to a text file. This is better because it will kind of compress your data a little bit. Let us just hit enter. Everything goes right. The table should have got created. We can ask for show tables right now. He's saying yes. Employee as well as employee 2 has got created. Hey, can you please let me know what are the records available in employee 2 folder? He's saying that there are no records available for now. Okay, looks cool. So now what you guys can do is you can say, hey, can you please insert? So we are saying insert into employee 2. Okay, so we are saying insert into employee 2. You typically start giving values, right? You'll say values like 1, 2, 3. But instead of values, which is something that we typically don't do, you can push from one table to another, right? So we'll say select star from employee. So that is all the records available in the first table should be used as the values, and those values should be inserted into what? Into the employee 2 table right now. So insert into employee, typically you say values is what, right? But now what we're going to do is we're going to say select the records coming from the employee table and please push it into this particular table. Now hit enter. If everything goes right, you can see he's actually trying to push it. So he'll create something called as map reduce jobs, etc., etc. Okay, so you can see it's working on this particular command. So you guys might ask me, why is it taking so much of time? You need to understand one thing, guys. You know, whenever you're going to work on a small data, right? Usually your in-memory technologies will be very, very fast. That is your Python, R programming, where it's all working out of your RAM, right? So those guys will be very, very fast whenever you're working on a small data. But when you go to a big size data, your in-memory technologies will not be able to work. That is, they'll not be able to fit the data inside the memory here. So random access memory, as the name says, right, it's pretty fast. So in-memory technologies will be pretty fast. They'll be able to store the data inside the RAM itself, fetch it, you know, play with it. But this Hadoop and all is not an in-memory technology. They save it in your hard disk. Hard disk is not very fast in IO operations. So that's why we say, and non-in-memory technology, that is somebody who's not going to use your RAM, right? They are very, very fast in handling big data, but when it comes to small data, they're going to fail miserably. So that's why looking at this, right, you shouldn't ask me a question, why is it going so slow? You told me that the computation time is going to come down. Yes, the computation time is going to come down, provided you give him pretty big data sets, massive data sets for him to work on. So these kinds of small data sets is something that this guy cannot work on pretty fast here. So now you can see it has probably taken 24 seconds, seriously 24 seconds. Okay. Now we can go back and say select star from employee, okay, _2. Now, the moment you do this, you'll be able to see that all the records are available within this particular type. So you based one table as a staging table and you've pushed it into another, right? So this concept is called as a staging table, if I'm not wrong. So from one table to another table, we were able to push right now. So this is also another methodology by which you can push your records inside one of the existing table. It may not just be a read from a particular file, but it can also be from, table to a table format here. Okay. So these are two examples that you have seen, guys, where the data is actually pretty structured. How can I create tables? How can I insert values into it is exactly what we've discussed now. Now, over to the next example. What I'm going to do is, I'm going to go back to local. Okay. We have one file called employee.txt, right? So the employee.txt was a structured data, correct? Now what we will do is we'll start using semi-structured data. Okay. I'm not going to give you an example of an unstructured data, okay, because that's not what we are trying to deal with. It's more of an understanding of how Hive and other people work. But I can give you an example of how a semi-structured data is going to probably work like. So let's go back and say gedit. I'll probably name this file as what? Let's say products.json, right? That's a file. We'll say products.json. Now we can go back and start giving different products. So we will say, hey, the name of the person is probably not a person, but probably the product is iPhone 6. Okay. Then the price of this particular product, we can probably say it is $600. Then we can probably say category. I think I have this file outside. Let's not waste time in not typing this out. Yeah, so the file is here. Okay, so what we're going to do is we're going to go back and store all this particular data here. So we are saying name is iPhone 6, the price, category, the color it has, the stock that we are holding, what are the tags. So we're basically storing these kinds of JSONs here, right? So this is one JSON file. The other one is actually another JSON file. You have another JSON. So we have several, I would say, dictionaries here, right? Several JSON objects, which you're creating as a single JSON file, something called products.json. You can just go back and close it. Let's do an ls. You have it here. You can ask for cat, that is, tell me what is available on the inside. He's going to print saying, hey, this is the file that we have probably created now. Okay. So he's able to print this particular file for us now. He's saying, hey, these are the different products available now. Okay, the different records. Now what we will do is, guys, we'll go back to Hive. A small point I want to add here is your Hive is not actually capable of solving unstructured data and all. I wouldn't say like it's directly capable of solving unstructured data or semi-structured data. You need to basically import a particular jar file. So what is a jar? Jar is more of a I would say a zip kind of a thing for Java related codes and all. So we need to go back and basically download a particular jar file here. Okay. So I want you all to do this. That is, if I'm not wrong, I should have the link here. So this is the link. I'll share it across to you all. So you should just visit this particular link. And now you can see, right? So he's saying Hive, JSON file, serializer and deserializer. So serializer, deserializer is basically what? It's more of a text parser. He's more of a parser here, okay? So Hive, a JSON parser, Serde is called as serializer and deserializer, okay? It's called Serde. So we are going to download a particular Serde. I have, I'm going to kind of use the snapshot thing. I don't know why exactly, but I remember doing this. So you need to take up this particular snapshot version. Now he's saying CDH is what? It's Cloudera, right? This HDP is, if I'm not wrong, Hortonworks data platform. CDH is Cloudera, whereas HDP is Hortonworks data platform. So you need to be using CDH, and we are using CDH5. The version that we downloaded, right, is 5.5. So you need to use a CDH5, and you should go ahead and download this particular jar file. So we have downloaded this particular jar file over here. Okay. Now what I will do is I'll take up this particular jar file. Okay. And we can go to your folder here. So we did create something, right? Something called class 2. What we will do is we'll take up this particular jar file and we will push it into that particular folder now. So we are pushing it into this particular folder now. So you need to download this particular jar file, guys. Only then he'll be able to understand. So we have downloaded it and we have pushed it here. So I'm just going to kind of rename this guy as plain jar. That's it. Okay. So this is a jar file that we have downloaded and we have kept inside our Linux system. We have kept it in a particular folder now. So what happens is, guys, your Hive, right, is not capable of directly handling all these JSON files. So the jar that we've just downloaded, right, is nothing but a Java code which is capable of looking at your text file and reading and parsing everything. Okay, he is capable of doing it. Your Hive naturally is not capable of doing it. So what you need to do is you have downloaded the jar, right? Looks cool, but you need to add it to the Hive. You need to make Hive understand that he has to use this jar to parse JSON files right now. So coming back to Hive, now we will probably go back and say, I think one more thing is we need to push it to HDFS, I guess. It can't read from local Hive. So we will say HDFS, DFS, put where in class 2, right? This is where I need to put, but from where should I probably put it? I should put it from home, Cloudera. I'll just use desktop. Class 2 is the thing. Here it is JSON Serde with dependencies jar. Copy this one and paste it here. Okay. So it can't read it from local, guys. So please make sure that you're pushing it into your HDFS. So HDFS, DFS, please put this local file into this particular folder. Now hit enter. If everything goes right, he should be able to push this particular jar to the folder. Now we'll go back and ask, hey, HDFS, DFS, LS, can you let me know what is available within class 2? Let's hit enter. He's going to tell us saying what? Hey, I think there is a JSON Serde 1.3.6 versions jar file available. Can you see? It is having the jar file right now. Now what you guys need to do is you need to go back here and just say add the jar file. The jar file's name is what? It's JSON Serde 1.3.6. And you have to give the path saying, hey, it is coming from class 2 folder. Within that, the jar file is available. Let's hit enter. If everything goes right, he should be able to add this particular jar file there. Okay, so class 2 slash, oh, dot jar doesn't exist. Why is it reading from local then? I guess it's reading from local then. Okay, let's check. Huh. So I'm sorry guys, I think it had to be on local, probably not from SDFS. Sorry. So it had to be on local, guys. I don't think it's reading from SDFS. It was just the opposite of what I just told. So it is reading from local, I guess, and not from HDFS. because you can see the previous case he was trying to reach out to the local, but there is no folder called class 2. So there's only a folder called home Cloudera desktop class 2. Okay. So this is a small change, guys. It's reading only from the local and not from your HDFS. So this is a change that you'll have to do. Okay. So right from the local only, we are actually reading it. And once you're done, it's saying that what, hey, I was able to add this particular resource successfully right now. So he is able to add this particular jar in this particular case here. Now what we will do is going back. So we have the file ready, right? The file, the JSON file is ready. And similarly, the jar file also is ready, who can parse this particular JSON files. Because Hive doesn't have a natural capability to parse all this, you need the JSON serializer and deserializer file. So now we will go and say, okay, I want you to create a table. The table name is something called products. Okay. So the different fields available are name, which is actually string in type, then price, which is integer type. Sorry, guys. Okay. So create table products, open bracket. It is name, which is string type. Then it is what? Price, which is integer or double, anything you can keep. I'll keep double. We can keep it as double. Then you have category, which is string in nature. Okay, you have color, which is also string in nature. What is this one? Seriously. I'm sorry, guys. Okay, so create table. This is name. This is your price. This is your category. This is your color. Okay. Yeah. So what else did we have? I think we had stock, which was integer type. Hit enter. Then I think we had tags, which was another one. Now for tags alone, we are saying, hey, it's an array. And the array on the inside, let it just be understood in the form of a string. So we're saying array, and within the array, it's all in the form of a string. We'll just hit enter right now. Now we can say row format. It's not delimited, but rather we are going to say it's surday. That is, it's serializer, deserializer that you have to use. From where is it coming or what is the name? So you have to say org.openx.data.json surday dot capital J SON SER, where S is capital, D is capital E. org.openx.data.json surday where J, S, and D is actually in caps. Now let's hit enter. And the next one should be the data, right? The next one is actually something called location. Now, once again, I have a confusion. So the location, is it supposed to be from HDFS? I think from HDFS. So we will go back and say, put this particular file. So what is the file? It was products.json, right? So we'll push that one also inside JSON. I mean, inside the HDFS. Okay. So you can see. So you'll have the jar file as well as the JSON file. Now go back here. You can say the location is nothing but class 2. It was class 2 slash products.json file. That's it, guys. Now you can just close it. So create the table called products, name, price, category, color, stock, tags, everything with their respective data formats. Now you're saying it's row format, not delimited. Rather, you're saying cert day and you're telling what is the cert day's name that you'll have to use and where is the location of this particular file right now. Now we will just hit enter. So cannot validate the cert day. Should I add it again then? Okay. Um, just give me a second, guys. So how did we add it? We just went ahead and said, hey, this is the guy, you have to add it. Should do it. Okay, so we'll just paste it here. So we'll say, hey, this is the folder where the dependencies is available. Let's hit enter. We should have added to the class path. Now we can just go back and create this thing again. Okay, I think copy pasting might work. Let's see. Okay, so it's a problem. Okay. So category, then we had what? Color. Okay. Then post color, we had stock. Then we had tags, isn't it? After stock, yes. We had this guy. Then we just have to go back and say it's row format survey, where this is a survey that he has to use. And then we can just go back and tell him that the location of the file is available here. That's it. Now just go back and hit enter. Now you can see, okay, what is the problem? So JSON is not a directory or unable to create it. Cloudera 820 class 2. Okay, so it tried to read it from the local right now. So there's another problem. So when it says quick start Cloudera 820 class 2, it tried to read it from that directory, guys. That's a problem. So let's do something. I'll just copy. Let me open a notepad here quickly. Okay. Okay. So it was actually at /home /Cloudera /desktop /class 2. Within that, it was available. So let's go back there, paste it. Now see, everything is okay, guys. So the first problem was that, the survey happened to be lost. You need to add it every time that you're going to use Hive, I guess. And here the second case is that this guy is once again reading it from local. Okay, so now we are saying this is the local path. And since everything has gone right, we can go back and ask for show tables. He should let us know all the tables available. He's saying products is there. Now we can just go back and say, hey, select star from products. So no files have got pushed inside. I mean, it does not load or anything. Okay, so this was the location, this was a file. Okay, this was unexpected. So what was going wrong? Everything was okay, right? So we'll just go back and do it again with a different file name probably. Okay, so even before that, let's just check it now. ls, we are here, cat products.json. So the things are available, no problems. Let's just do a gedit anyways quickly, and this extra space and all, we can remove it. We'll close this guy here now. Let's just go back here and we can just paste the code. Okay, so select star from products to hit enter. Why is it not loading it? So we had name string, price is double, category string, color, stock integer, tags, stock tags here we are saying it's a string only then. Okay, category, color, stocks, everything looks good. It did work for me, but what is the problem now? Okay, I'll check this particular example, guys, but it did work for me. I'm not very sure why it's not able to load the file right now. It had to be, or I guess I now know what's a mistake I'm doing. Okay, so let's just go back here. I guess it's only the folder if I'm not wrong. Yeah, I think now it should have probably worked, but let's see. So select star from products 3, still not. Okay. So I'll check this particular thing, guys. Ideally, this is a method. I don't think there's anything wrong. Home Cloudera desktop class 2, this one, row format Surday, tags, products 3. I think everything is going right, but why is he not able to load it? I'm not exactly sure. Okay, so this is the JSON Surday. This one, I think it's good. I'm not very sure why it's not probably working. Or just give me 1 second, guys. I'll just quickly look at the Surday. I used a different Surday probably yesterday. So this is what 1.3.6, exactly the same one. 1.3.6 with dependencies. This is the same one I did use yesterday. Okay, so I'll probably check on this one, guys, and I'll let you know, in the next class. Let's not ponder over it anymore. But I think it's probably the JSON Surday. I'm not very sure which Surday are we supposed to use, but I guess it's this one. Shouldn't be usually a problem. Okay, but I'll probably check in the next session and I can let you know on what exactly is going wrong here. Okay. So this is one another example that I wanted to kind of quickly discuss on, how do you uh, create tables and, how do you probably load unstructured data, or rather I would call it as a semi-structured data, right? Coming from this kind of, file here, probably a JSON file. How do you use Survey to probably do this particular thing? Okay. So now probably I'll just go on to a last example, guys. Let's try to do some joins and all, okay? So let's keep it simple. I'll just create a quick file called emp.txt. It's called employee.txt. Let's just create a couple of files, couple of records. So let's say the person's name is Jack, and probably he's earning $500, and his ID number is, let's say, 101. Number two, let's say the person's name is Jill, $600, 101, probably the same department. Three, let's say it's Andrew. I'll assume he's probably earning $700. You'll say department number 102. And four, I'll just call out somebody like Tom. So $450, we can probably just go back and say, hey, it's 103. I think this is enough. 4 records, 1 txt file. Quickly over to another txt file also. We can just say department.txt, and we will say for depart number 101, it's actually, let's say, engineering. Let's say for 102, we'll probably call it as HR. For 103, we can probably call it as finance. Let's save it and we can close it. So there are 2 files you've created. So quickly, 2 tables we can create. So create table EMP. So the first thing we had was ID, right? ID of integer. Second was the name of the person, which was string. Next was the salary he was earning. So I'll probably call that as double because I remember giving 0.0 if I'm not wrong. Then department ID, we can call this to be an integer right now. Okay. So now hit enter. Row format delimited. Now then you can say fields terminated by a pipe symbol. Oh no, we didn't use a pipe symbol, right? We used a tab. So /t. So we are saying by a /t, and now we'll just say stored as text file right now. It's basically a format by which it will save at the backend. So we're saying store it as a text file. Now we will say, hey, I want you to load data local, right? Because it's in local in path. Where exactly is he sitting? He's sitting at home, Cloudera. Then there is a folder called class2, or even before that there is desktop, right? In desktop, class2. And here within this, there is a file name, something called emp.txt, right? And where do you want to load it? Into a table name, something called emp right now. You just hit enter. So go back and say, hey, select star from emp. It'll tell you all the records. Similarly, in the same fashion, create table department. ID is integer, name is probably string. Same old things. Row format delimited. Okay. Then fields terminated by what? I think what did we use? Cat dept.txt. It was a tab again, right? So we'll just go back and say, hey, it's a tab here. It was separated by a tab right now. And now we are saying, hey, I want to store all of these people probably as a sequence file or whatever it is. So we'll just say text file. Okay. Now load data local in path. I'll just go and copy this entire path now. Okay, so it came outside. Okay, so load data local in path. So this is the path, right? And the file name was dept.txt if I'm not wrong. Into table department right now. Let's hit enter. If everything goes wrong, he should be, sorry, everything goes right, he should be able to upload it. Select star from dept, let's ask it. So everything is there, okay? So the 2 tables are available, guys. Go back and ask for show tables. Select star from emp. That is for table number 1. Next was dept, that is table number 2. So both the tables are available right now. So now what we can do is you can just do a couple of joins. Okay, I'll just help you all understand how to do joins. I think we can just go back and say, hey, select, let's say, e dot name. Okay, and I'll just say A dot name, comma, B dot name, comma, B dot let's say department, okay, from A, where I mean A needs to be called as EMP, that is from this particular table called EMP, giving it a alias something called A. Join it with DEPT department, you're giving it an alias something called D. On what condition? On the condition that E dot department ID should be equal to B dot ID. So I think there are a lot of mistakes we are doing. So here we kept it as ID if I'm not wrong and not the name, right? And here we kept it as what? Department only. So let's check it anyways. Let's just hit enter. So failed. Why? Because EMP department had to be B right now. B. Here it's A. Okay, invalid column. I know it because describe DEPT. He'll tell you what are the column names. It was name. Okay. Okay. Now look at this query, guys. So we are saying select from a table name called A. What is the column? I want you to select the variable name. From a table called B, I wanted to choose ID and I wanted to choose the name. That is the department ID and the department name. And here it will be what? The person's name, if I'm not wrong, right? So I wanted to basically join both A and B, that is EMP and DEPT table. On what condition? A dot department ID is equal to B dot ID. I just go back and hit enter. If everything goes right, he should be able to, kind of create a join right now. Okay. So this is an inner join, right? If I'm not wrong. So he has created something called as an inner join. Similarly, you can go back and ask for, let's say, left join, right join, probably a full outer join, right? So any kind of joins you want him to probably do, you can go back and tell this guy. Now, can you see? He has probably done an inner join, if I'm right, Yeah. He has done an inner join, and now he's letting us know that these are the 4 records where Jack, Jill, Andrew, Tom, everybody has department IDs matching 101, 102, 103, where the department names are basically engineering, HR, and finance, right? So this is exactly how you can do joins, guys. And the same example here, you could have just gone and said, why don't you do a left outer join? Right? He'll do a left join for us right now. Or how about a right outer join? Or how about a full outer join? So those are the names. So here it's a left outer join that he is trying to do. Okay. In the next case, we can try a right outer join. Probably then later on case, we can say it's a full outer join. Right? So he'll be able to do all these join related operations also here. Okay, so you can see. Now this is a left outer join. It's actually the same thing, right? So it should be the same thing. So no problems at all. So he's able to do this particular query also. So you can try more and more queries, guys. Similarly, you can write a where statement and all if you want. So I can just go back and say, hey, select everything from the employee table. But I think it's a where condition like this directly, where I think what name is equal to Jack, probably something like this. Can you see? So select everything from the employee table where you have this particular condition. So you're saying this is the condition. I want you to select every column, but only when the name is probably Jack, let's say. Or you can just go back and write a condition saying, hey, the salary has to be less than probably $500. You can hit enter, he'll query and he'll let you know. So it's the same whole thing, guys. If you understand how SQL works, SQL works, it's the same thing. Here it's called as HiveQL. That's it. It's called HiveQL. It's basically a SQL version, especially for Hive. That's it. It's the same thing that you're going to write, right, with small changes here and there, and it's capable of handling pretty massive data and even semi-structured or even unstructured data. provided you call the right jar, you link it, and then you ask them to start working on top of it. Okay. Yes. So following till here, guys, any questions on Hive here? Did you all follow these examples on how did we do, what did we do? Okay. Any questions otherwise? Uh, yes, Manohar. So if there's any unstructured data, you need to, go back and pull out the specific jar files and all and start using it. This is one thing that I know, which I've used previously. So, I have an example here. But for any other kind of files, there should be some jar files available. So we just have to do the right search, right jar files, just download it and start making use of it. The jar file is more like a Python code which is already, a Java code which is already available. So you're just using that Java code to do all this parsing here. So I think, yes, that's what we should be doing. Okay. So in the same case, guys, you can do group by statements, etc. also. So suppose in case you want me to show a couple of examples, let's do that. So we have show tables, right? So select star from, let's say, EMP. Okay. So now we can just go back and say, hey, I want you to select, let's say, the department from the table which is EMP. Okay. But group it by, let's say, for an example, the department column. So we can just go back and say, yeah, I wanted to select this particular department and probably even find the sum of salary that these guys are taking from the table, group it based on department here. Now you can just hit enter. So department from EMP, group by department. So he's saying department, possible department ID, is it okay? So ID then. So now you can see. So what are we saying? We are saying, hey, I wanted to select the department ID and the sum of all the salaries that the department has been paying from this table, but please first group it by the department ID here. So find the groups of different department IDs and tell me what are the department IDs and the sum of all the salaries that these guys are probably drawing here. So that's exactly what we have asked. So looks like the query is okay. He's probably trying to produce some results. So can you see it's all map reduce jobs, right? So you should be able to see the words and all saying map reduce started. If it's not so, it's okay. Here you can see it's saying map is so much, reducing is so much. So it's on map reduce job. So number of mappers are 1, number of reducers are 1. So now you can see for department 101, 102, 103, the total salaries paid are $1,100, $700, and $750. Or probably in the same case, you can go back and say, hey, I also want you to order by, let's say for an example, the department ID in a descending order fashion. If you don't want it in descending, you can leave it like this, which is an ascending order fashion. Or you can specify a descending order by saying DESC. You hit enter. If everything goes right, he should do the same group by, and he will order this entire table by the descending order of department ID right now. So you should see 103, 102, and 101 right now. Okay. So the same SQL statements, guys, if you're okay with SQL, let's say in other products, then it should be the same even with your Hive also here. Okay, so you can see it's doing some map reduce jobs and all, and it's trying to fetch some output for us. Yeah, so now you can see it is ordered it by a descending order of this particular department ID also. So it's able to, do this descending order sort. using the order by statement that you've written in your SQL command here. So this is exactly how you leverage Hive, guys, whenever you want to play with some massive data, right? So the Hive is going to take care of doing all these jobs in a MapReduce kind of a fashion. He'll handle all the heavyweight and he'll be able to query the databases or the tables that you have created, and he can present the results right in front of our eyes. Okay. So this is exactly what a Hive has got to do. I in fact had another example for the JSON survey, but unfortunately, since it's not working, I'm not going to pull out the other example. I had two examples on JSON survey, but anyways, bad luck. It's not working. Okay, great. So any questions still here? I hope everybody is okay, right, with this one. Any questions otherwise still here? Can we move on to the next topic probably? Okay. So now we will just quit this particular, Hive terminal by saying quit colon Control L would clear the screen. Okay. So we have completed our discussion about HDFS, Yarn. We have spoken about Hive. Now what we can do is, guys, we can quickly talk about Scoop also. Okay. So Scoop is also another beautiful tool that we need to understand, or another beautiful, product of the Hadoop ecosystem. So Scoop is more of a data ingestion tool. Okay, so a Scoop is basically a tool which is capable of ingesting data from one source to a destination, from one place to another place right now. Okay. So once again, now suppose in case you're somebody who's working not on Cloudera, then you need to go back and download all the jars of Scoop, etc. Okay. And within the Scoop, what you need to do is you need to go to something called as lib library folder. Here you need to add a lot of jars for connecting to any ODBCs that you have. Say for an example, this is the Oracle ODBC. I had to download and place that jar. This is a MySQL connector. I had to download and keep that particular jar. I don't think in Cloudera it's a problem, but if you're somebody who's using on any other versions or any other, let's say products, then you should be downloading all of these products like this, configuring it, and also making sure that the jars are available at the relevant areas. So now in our case, it's very simple. So we're going to start off with a very simple one. We'll just ask what is the version of Scoop that we have here. I think just -v or -version should do it. Let's check. Okay. Okay, then I think it's -v. No, I mean, what is this guy doing? Okay, so I think just Scoop version. Okay, looks good. So now you can see we have asked for the Scoop version, guys. He's letting us know that the Scoop that this guy is given us right now is what 1.4.6. It's your Cloudera, distribution version that he's actually using, right? And what else do we have? It has got compiled by Jenkins, etc., etc. Okay. So this is exactly what we have right now. We have understood what is the version of the Scoop. So this Scoop over here is going to help us transfer data from one place to another. Okay, so we're going to be looking at this particular guy who will help us transfer data from one place to another place right now. So what we can do is, guys, we can quickly look at a couple of examples on how you can use this Scoop to transfer some data. Okay, so just give me a second. Okay. Yeah. So it always starts with the Scoop command, guys. Okay. Whenever you say Scoop, it means, you're calling this particular component of your Hadoop ecosystem and you want this guy to start working. Okay. So we're saying scoop. Do you want to import or export? What do we have to do? You need to specify him that particular thing. We are saying, hey, I want you to probably import something. So we are telling him that, hey, I want you to probably import something right now. Okay, cool. So what exactly do you want me to probably import now? So we can say import by connecting. So we are saying import by connecting to JDBC colon. I'm going to connect to MySQL, guys. Okay. So by the way, there was another smaller point I wanted to add. So you can in fact log into MySQL like this. So you can say MySQL -u, which is a username. Username is root, and -p, the password is Cloudera itself. Okay, so you can do it in this particular fashion, or there's also another thing. You can say MySQL -u, which is root, and -P. Now he'll ask for the password. Not capital P, small p, then small p. He'll ask for the password. So typically it's not good typing the password in the command line there. Now this is more of an encrypted version. You can type your password. The password is Cloudera. Hit enter. You can see he has gone inside MySQL. Same thing, guys. Show databases like what you did in Hive is going to let you know what are the databases. Now we'll say, hey, can you please use something called Metastore? So we're saying, please use the database, something called Metastore. Now we will say, can you please show the tables? These are the different tables that he's actually showing for us. Okay. So now you can see, guys, there is a table, something called TBLS itself, isn't it? I told you all yesterday, no, that the Hive will basically keep its metadata in MySQL. That's what we are actually discussing. So we can go back and say, can you please select all the records from TBLS here? Let's hit enter. Now he's going to tell you all the different tables that you have just created here. He's saying what? There are tables like employee, employee2, product, product2, product3, EMP, DEPT. You've created all of these tables is exactly what he's telling us. Right? So he's saying these are the different tables you have created, by whom, at what time, what is the ID. So the MySQL is going to keep the metadata about what are the different tables you have created here in Hive. So what I'm going to do is, guys, if you see our MySQL, right, when you look at the databases available, these are the different databases available, correct? So we can just go back and say to your scoop that, hey scoop, I want you to probably import, okay, import what? Import probably data by connecting where? JDBC, okay? So you're basically saying it's JDBC connected, MySQL colon / where is the URL that this guy has been hosted? We are saying it is more of a local host. You don't see any URL. It's more of a local host that we are hosting this particular guy. Then we will say colon 3306 is the area where he is actually running right now. And then we will go back and say the username required for you to log in is nothing but root, and the password that you need to log in is something called Cloudera. And now we can go back and specify, please use one single mapper. Okay, so mapper is more about like processes. So we are saying please use only one single mapper, and you can hit enter. So okay, so is there any error messages here? I don't see any error messages. Okay, so what actually he's trying to do is he's trying to import, okay, basically this particular MySQL, but there's still a problem. Okay, we still haven't specified which table and all to import right now. There's still an error that we're doing. So we have basically asked him to try importing something, right? So we are asking him to basically do what? To import something. Or even before that, you can do another thing. You can ask him to basically go back and try connecting or even list databases. So instead of import, guys, let's start with a different example. Let's ask him to list the databases. Scoop, can you please list the databases in this particular area? Let's hit enter. He should ideally tell you the databases here. So what's the problem? You don't need a mapper. Okay, now hit enter. Can you see? He's listing all the databases available running at this particular MySQL instance, right? So we said scoop, list the databases by connecting to this particular MySQL instance. These are the usernames and the passwords I want you to use. Now we can say, hey scoop, I wanted to import data, okay? I wanted to import data by connecting to JDBC colon MySQL colon / localhost colon 3306 / do you have any database with you? Yes, I think I have a database, something called Metastore. Okay. Then you can specify, I wanted to import what table? A table called TBLS. What is the username? The username is basically root, right? And what is the password? The password is basically Cloudera right now. So we are saying, hey Scoop, please import by connecting to this MySQL instance running at 3306. This is the database, something called Metastore database. The table I want you to import is TBLS. Username is root, password is Cloudera. The point is, guys, where is he going to import? Since you have not given anything, the import is actually going to work in your HDFS right now. So let's just hit enter. He's trying to import it from your HDFS. By the way, you need to specify mapper. Okay, and what is the problem? Setting up this one, got error, no manager string 3306. No, I think it should be probably okay. Connect JDBC colon MySQL colon / localhost colon 3306 / Metastore. Okay, so he's saying no manager for connect string. This is surprising. JDBC. Okay, I'm sorry guys, there was a spelling error. It was JP something. So let's hit enter. So now you can see he's actually trying to import. Looks like there's a bigger error. Not even an error. Is there anything else? The last packet sent was success. Okay, I don't think it was probably an error. Here it's an error. No columns to generate for class writer. Okay. Unknown exception, localhost L spelling wrong. That is a problem. Okay. Yeah, now it's working, guys. So you can see here, still a problem. What is this? TBLS already exists. Okay. Okay. Anyways, STFS. Okay. So TBLS is actually already available. I'll just go back and delete it, right? Okay. Okay. So see guys, I'm sorry, going back here. So we are saying scoop, I wanted to import by connecting to this particular MySQL DB, import the table TBLS, username is root and password is Cloudera. So the moment you hit enter, if everything goes right, he should be able to read this particular data and save it in your HDFS. By default, it's going to import it to the HDFS only if you don't specify him saying that, hey, you need to import it somewhere else. So he's trying to import everything from that particular table and it's trying to store it here in your what? In your HDFS right now. So let this guy complete. Okay, so I think everything is good. So he's saying, yes, I was able to retrieve 8 records and have transferred 55 bytes in 36 seconds. Now what we will do is we will say HDFS, DFS, LS, not even coming to the root. We are giving it as it is. He's going to tell us what are the directories available. There's one directory called TBLS. Now you can say, hey, slash TBLS. Within that, can you let me know how are these particular tables stored? You will be able to know that these tables or this particular output has got saved in the form of a binary file. Okay, so let's just hit enter. There's no file or directory. This guy is actually troubling me. Serious. Okay. Now can you see? So this is basically in the form of a binary file, guys. It's splitting the file and it is saving in the form of a binary file right now. The data that you've imported, right? It is actually saved in the form of a binary file in this particular case, which means you can't really view what is happening on the inside. It's getting stored in the form of a binary file here. So now what we can do is in the same previous command, right? We can also specify the target directory. So what can we do? We can also specify the target directory. So we can say the target directory is slash, let's say, I'll call TBLS. So he's going to create one and he will save it there. So what are we saying? We're saying right now, the target directory is over here. I don't want you to save it anywhere that you think. So this is the target directory where I want you to go back and save it right now. So the moment we hit enter, you can see the process is starting and he's trying to save it in that specific target directory you've asked him to save now. Yeah. So now you can go back and ask HDFS, DFS, LS slash TBLS. Can you let me know if there's a directory there? Is there any files there? Now, once again, you can see there are 4 files. These are all basically binary files over here. So what are they? They're basically binary files, right? Now, similarly, there is also another couple of commands, guys. You can import many tables at a single shot. Okay, so you can go back and say, hey, scoop, right? Instead of saying plain import, you can say import all the tables for me by connecting with whom? Or shall I just go back and rewrite this one itself so you can see? So we can say instead of doing a plain import, you can import all the tables for me by connecting to this particular library. We are saying all the tables, right? So this guy should be removed. So we are saying, hey, this is the database I wanted to connect. This is the username, password, everything. And now you can give your Tarek directory also. You can say you can probably use one single mapping, one single mapper also, or you can remove this also. I think it's better off we remove it. Now we can just go back and hit enter. What he's trying to do is he's trying to import all these files right now. So what is the error? Import all tables, username, root, password. So in username, there was an extra dash. That's the problem. Okay, let's go back and hit enter. What else is the problem? Error parsing arguments, import all tables. Import all tables, it's correct only. Okay, target directory, we didn't remove it. Yeah, now it's good. So you can see a scoop, import all tables by connecting to this particular database. This is my username and password. You may use one single mapper right now is what we are saying. So he's trying to import all the tables available in this particular database to our HDFS right now. I think it's going to take quite some time. I should say thanks to you guys for being so patient. I think we'll just close the process. It's just a little too much. So we'll say HDFS, DFS, and -ls. Ideally, those processes should have got completed. So some of the tables should be available here. Can you see? Columns V2, compaction cube, bucketing columns. Some of these tables have got imported right now. Similarly, in the same sense, in the previous call, you can also go back and say, hey, can you please exclude these tables? I don't want these tables, okay? I don't want probably the TBLS. So you can go back and specify what all tables that you don't want probably. And then you hit enter, he can exclude those tables for us. So this is exactly how you import data to what? To your HDFS guys from a different source. So the source right now was basically a MySQL source. From MySQL, he tried to import this particular data inside HDFS here. Okay. So now what we will do is, we look at another beautiful example, guys. We'll try to export data from HDFS to MySQL, just the opposite of it. So in the previous case, what did we do? We said, hey, whatever is available inside MySQL had to come down to your HDFS, right? He started storing them in the form of what? In the form of binary files. Now it's the opposite. We are saying from HDFS, I want you to push it into MySQL. So let's do that. So let me go to MySQL. Before we even push, right, we need to create a schema there so that he can understand that. Right, that is very important. So only if you give him the schema, he'll be able to understand that, correct? So let's go to MySQL. MySQL username is root, and then P is password. Password is Cloudera, hit enter. So he has gone on the inside. Now we can probably say, hey, can you please show the different databases you hold? So these are the different databases. Can we just, let's say, create a particular database? Create something like sample. Okay, it's called create database called sample. Okay, now we'll say use this particular sample. Okay, so he's going to use it. Now we'll say show tables. There should not be any tables right now because it's an empty set, right? We just created it. Now we'll create a table, guys. We'll go back and say, hey, can you please create a table? I'll call this guy once again as probably SAMP, probably not sample, but SAMP. So the fields that this guy is going to hold are employee ID, which is of an let's say integer type, comma, let's say employee underscore name, which is a varchar, which is of 10 types. Then we can probably say employee salary, right? I'll probably call it as integer. Okay, and then finally over to date, which is of a date type probably. So if everything goes right, he should create a table. So I think the query is okay. So we have given the respective types, everything here, and we have created the table. So now you can ask for show tables. The tables are available. Now if you say, can you please select star from SAMP? He's going to say no records for me to show. It's an empty set here. Okay, looks totally cool. Now keeping MySQL aside, let's go to let's say plain local, or let's say probably to HDFS. So what I will do is, guys, I'll create a quick file right now. Okay, I'll call the file name to be what, something like emp.txt. I'll just do it. It's okay. We'll say emp.txt. So we had employee ID, which was 1. Then we'll have the name of the customer. I'm sorry, the name of the employee, which is, let's say, Jack. then we can probably say that the salary he was getting was $500. The date was 2011. Let's say 0105. Second guy, who's probably Jill, he was getting 600. 2012, 0101. We'll say 3. Let's say it's Andrew. We'll say 450. 2013, 0101. We'll save it. Okay. Do ls. So you have this emp.txt somewhere here, I guess. He's the guy. Right? Now we can just go back and say HDFS DFS. I wanted to put this particular file. The file is, if I'm not wrong, home Cloudera /emp.txt. Inside where? Inside, I think we created a folder called class 2, right? We can just push it into class 2 itself. Actually, I think you should update it, not throw an error. Anyways, yeah. HDFS DFS -ls /class 2. So now you can see within the folder, this file is right now available, emp.txt. Now let's go back to Scoop. So using MySQL, you have created the table, guys, so that he can store the records. Here you have created the records. Now over to Scoop. Hey Scoop, the previous time we did imports. Now we're going to do an export. So we're saying, hey boss, it's an export. I wanted to connect to this particular guy, JDBC : MySQL : localhost : 3306, and which database? I think the database was called a sample, right? And now we just have to specify the username, which was root, the password, which was Cloudera, and also in which table should he push this one. The table was SAMP, if we are not wrong, right? And now we need to specify where is the export directory. That is, from which directory do you want me to export right now? So we can just go back and say, I want you to export it from, it's only directory, no, not file, which means there's a catch here. We'll just delete these two records. It's a directory, guys, so it needs to be inside a directory only. Other files cannot be there. That's why I'm removing this guy. I'll remove the products.json also right now. Okay. Yeah. So right now, if you check, this directory has only one single file. The only file we wanted him to upload, emp.txt. Now we can just go back and say, hey, the directory is nothing but what? Class 2 and / here. That's it. The number of mappers that you can use for this particular job is 1. So Scoop export, please connect to this particular MySQL database. I wanted to export this table whose username password is like this. And export should happen from the directory where this is the directory right now. Let's go back and hit enter. If everything goes right, it should push the data from this directory, that is a text file, inside our MySQL database. So you can see it's connecting to resource manager and all, running this particular job, URL to track it. Oops, there is an error. Can't export data, please check fail map task logs. Okay, I remember this. I got this error, and in spite of it, I was able to push the data. We were doing something. So what did we have to do? Class to everything. Actually, it'll still give you the data if I'm not wrong. Select star from SAMP, right? SAMP. That's still empty. Okay. Table export directory M1 localhost / sample username. Scoop export connect JDBC : / localhost 3306 / sample. Yes, we're good till here. Hyphen username, password, the table, and export directory. This is a directory M1. I think everything is good. Hmm. Go to zero records. Status failed. So let me go over again. First is we should have created the table, the database. We did that. Then if we had checked it in this particular database, this table would have been there. So show databases and show tables. SAMP is available. Then we said select star from SAMP. We saw it's an empty set. This is also correct. Then we pushed it into Hadoop system. So HDFS, DFS, LS slash, what was it? Class 2. And we'll just say cat, cat class 2. And it was basically called as what? emp.txt, right? So these files are available. I think I got the mistake, guys. I'm sorry. So the mistake is it should have been comma separated. So the data should have been comma separated. That is exactly the mistake, I guess. It's not tab separated. The data should have been comma separated. So class 2 is here, emp.txt. It should have all been comma separated. Okay, so this one. So it should have been comma separated, guys. That's the problem, if I'm not wrong. Let's go back and push it again. So this is overridden. Okay, so we'll go back and ask for this particular file to be printed. Still, why is it not comma separated? And, okay, I think the mistake was we were editing the wrong file. It's just too many mistakes we are doing today. Or I'm doing. Guys, I'm sorry. So we were editing the wrong file till now. So this is the file we should have edited. Are you guys paying attention? Has nobody corrected me for any of these mistakes here? Okay, so now we are cool. So I'll just go back and delete this particular file again. Okay, so we can put the file back in place. We'll ask him to print it again. Okay, now it's good. Let's go back and run our scoop job right now. So you're saying export this file into this guy. Now ideally it should work. There's been one dot. It was not a comma. It was a dot. It was full stop. Okay, so finally, so there are no errors in this case now. So now we can just go back and ask for the records here. It has worked, guys, successfully. So it had to be a comma separated file. That was the only issue we had. So after making it as a comma separated file, this is the command. We're saying scoop, I wanted to export from this area. The username is root, password is Cloudera, table is this one, the export directory. Where should you export it from? You need to export it from this particular directory. That's exactly what we've given as the user. I mean, input now. Now he's able to export it from there. Okay. So I think we'll look at a couple of more examples, guys. With that, we'll call it a day. Okay. So I don't really think it's working out very nice. So what we just did was, in the first case, we imported data coming from MySQL to HDFS. In the second case, we pushed it from HDFS to MySQL, correct? Now, how about from two different sources, I will try to kind of import them. Let's say it's something that doesn't involve HDFS at all. How about between MySQL to Hive? This is also very common. Very commonly, you'll be doing it. So we'll just go back and say, hey, Scoop, I want you to import. Okay, so we are saying that I wanted to probably import by connecting to JDBC colon, it's MySQL colon / localhost colon 3306. Okay, JDBC colon MySQL colon / localhost colon 3306. What do you want to probably take up? I'll probably say there is a database called sample. The table is something called SAMP. I want you to probably do a Hive import. So we are saying connect to the database MySQL DB, and I want you to import it to Hive right now. So I don't think for Hive you would really need to create any schema and all. It should be able to do it directly, if I'm not wrong. So let's hit enter. Okay, so scoop connect JDBC colon MySQL colon / localhost colon 3306 table Hive import, right? I think you're good. So Hive import. Localhost spelling is wrong. It's a L. Once again, the same mistake. Okay, now what is the problem? So, okay, now the problem is access. Okay, so we need to say the username is something called root and the password is something called Cloudera. Just hit enter, that's it. So it didn't have the accesses. So now can you see from MySQL, it has tried to push into your, Hive. And now mapper is one. That's also another input you need to give. So tell him that there is one mapper that he'll have to use. That's it. You just have to hit enter. Okay, that's it. So now what we could do is we can probably open up Hive somewhere here. Okay, so we wanted him to import it into Hive, right? So let's go back to Hive. So now let's say show tables. So sample is here. Now we can just say, hey, can you please select all the records from sample? You can hit enter. Now you can see all the records right now is available in the Hive table sample for us, right? So this is a import that you are able to do from one source to another source right now, guys. From let's say a MySQL database to probably a Hive database right now. And now there are a couple of more things that we can discuss. One is like you can write a where statement. So you can say conditions like probably I want the date to be lesser than 2012-0101. So you can give conditions also something like this here. So in the query that you're writing itself, you can give certain conditions. You can write some, where statements, or you can also, specify which columns you want them to select. Even that is something that you can input here. I really think it should give you an error probably because the table names are going to conflict, but let's see. Okay, so far so good. Yeah, I think it's good. So go to Hive, say show tables. So sample is here, select star from SAMP. So this is what is the result we have. So ideally he hasn't overwritten, and then what did this guy do? That is a question that we need to ask. Shall I just drop this particular table? Drop table SAMP. So we'll drop it. Now we can run it. We want the date to be lesser than 2012-0101, right? Yeah, let's hit enter. SAMP Hive import username password where this is the condition 2012-0101. Okay, so let's go back here. Show tables. The table has got created. Select star from SAMP. Now can you see there are no records? Why? Because this guy has probably not satisfied the condition 2012-01. I think one record at least should have been there. Anyways, so now you can see that previously we dropped the table. Now the query has run, and after the query has run, you're able to see that probably there are no records. I was thinking there should have been one record, right? 2012-0101. Anyways, so you can write this kind of where statements also, guys, in your scoop, queries here. And there are several other things like, probably you can write a query something like this also. So you can go back and say, instead of where, you can in fact write a query itself. So you can write a query something like select, let's say, the count of, or let's say the sum of, okay, but the sample is gone. Do we have products? What do we have in MySQL? This is there, right? So okay, so we can say, find the sum of emp underscore salary from what? The emp table. Okay, so this is a query that you're writing, and where are we going to execute this guy? We're going to execute it. You don't need to specify the table. He's going to do it. Sample. There is no Hive import here. You need to specify the username and password. And then instead of import, we will just go back and say eval. So you're saying Scoop, can you please evaluate by connecting to this MySQL database? This is a username and password. I'm not very sure if you need a mapper, but let's leave it. Then you're saying this is a query I want you to execute. So it is not just for like importing, exporting, but can also write queries like this. I think the mapper is the problem. We'll remove the mapper. Okay, so it's all warnings, right? Sample.emp doesn't exist. Okay, in MySQL it was sample, right? Then there was emp only. SAMP. So we were using sample, right? So what is the problem? So sample, from there we wanted not emp, SAMP, sorry. Okay. So now can you see, guys, he's also running certain queries for us and he gives you that result here, right? So we are saying that, hey, I wanted to evaluate, this particular query for me, where this query has to be run by connecting to this particular database. This is the username and the password that we specified. Right, so this is another use of your Scoop tool right now. But otherwise, I think we've pretty much seen a lot of examples, guys. In fact, like while importing, one more thing that I can probably add is, so this guy is right now trying to import something, right? Importing into HDFS. You can ask him to import it as a text file if you want. So you can tell him, please import it as a text file, not a binary file, but as a text file. Similarly, you can ask him to save it in the form of something called sequence file. So these are all basically formats which will not take much of a space. There is a compression that's happening. Similarly, you can have, let's say, an Avro format. It's called Avro data file. You can have OCR. These are all different formats, guys, by which he's going to save this particular data here. Okay. So I don't think anything is wrong. So Avro is not allowing. Then how about sequence file? Okay, sorry, there is a Hive import command here. We should remove that. Okay, now it should be good. He's trying to import it in different formats, guys. So this is called as a sequence file. Next example, we'll look at a Avro format probably. Then we look at a text file probably. Okay. So similarly, you can just go back and say, hey, I want probably a Avro file. So Avro is also another format by which you can save it. It's a Avro data file. You can hit enter. So it's a Avro data file. He's going to save it in that particular fashion. Okay, it already exists. Okay, whatever it is. So HDFS DFS -ls, you can just go to this particular guy called SAMP, probably SAMP or whatever it is. Okay, he'll be able to let you know that these guys are available here. It'll be of certain formats. It will be Avro or sequence or text file, whatever we are telling here. Okay. I think that's it, guys. So this is exactly what I wanted to kind of discuss today. One was Hive, a couple of examples, but that Surday didn't work exactly perfectly. Like next was the Scoop. Scoop is also very simple. Once you understand the syntax, once you understand how the behavior works, even this day is easy, right? So you just have to give the right arguments and give the right inputs, then he'll be able to work. So you just have to understand the tool, guys. So getting into the programming perspective, something I don't really think you need to know a lot. Just understand the tool as a whole, how it's kind of working out. Okay. 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 So now only you see a lot of questions. I'm sorry, guys. Okay, so first question was, only if it is stored as a sequence file will be able to push data in it. Not exactly. You can save it as any file. That is, 4 file formats are there: text file, sequence file, then there is ORC, then there is Avro. Okay, so there are like 3-4 different formats. You can store it in any format. So it's more of a compression technique. ORC, Avro, and all, right? They're all good compression algorithms. So ORC or OCR, ORC file format. So these are all very good compression algorithms, actually speaking. Can you see here? So plain text file, if you have, it would have been 585 GB, but in RCF file, it'll be 505. In Parquet type, it'll be 221. In ORC, it'll be 131. Avro is more of a Hive format here. So these are basically different formats of saving the data within your HDFS. So it's a compression technique. Okay, so I remember the compression name also, Snappy. So the compression name used to be Snappy compression, if I'm not wrong. Okay, Snappy compression. Can you see? It's called Snappy compression. Okay, so this Snappy compression is something is what is typically applied in the Hive here. So this compression technique will give you this, data files and all, which is getting saved, which are very small here. So you can see it's 78% smaller compared to a plain text file. So that's why in Hive, when you're storing it, you can store it as these formats. Okay, so that was one question. I think I missed out another question, which was for unstructured data, any specific jar? I think we discussed this one. No, I did notice it. So yes, we need to ideally pull out certain jars. So can you show us how you connected to MySQL? Okay, so MySQL was, if you have a new tab like this, you have to say MySQL -u and tell them what is the username, which is root right now, -p. You can write your password here also, it's okay, but don't do that. It's not recommended. Just say -p and hit enter. Now he'll ask you for the password. You just have to go and hit enter. Now, if you do it, your MySQL command line will open. As regularly how you will do it, just ask for show databases, ask for show tables, and you can start working with these guys. Okay, so this is exactly how you get into a MySQL command line here. Okay, so there was another question. So can we join or combine multiple data sources and one flat file, one from DB imported into HDFS? So can we join or combine multiple data sources? Probably one flat file and one DB. But join where exactly? In the scoop part, are you saying, Manoj? So joining files in the scoop? I don't think so, probably. Not an expert at it, but I think I haven't seen much examples, so I don't think so. It's probably, no, that's what I don't think in the query it might be possible, because in query it's always one connection. Okay, so if you have multiple sources and all, it's not probably possible. It's like execute a particular query in that connection. So I don't really think it can probably handle multiple connections and do data joins and all. I seriously doubt it. It might not probably work, is what I feel like. It might not work out, or it might not be possible, is what I think. Okay. Yes. Actually, I was thinking of doing Spark today, guys. In fact, starting with Spark today, but I have a lot of issues in Spark here. Okay, I'm not able to import a couple of things you can see here. So there are a lot of problems within this MySpark that I have here. So let me just check. Okay, for probably for the next weekend, we can take up the PySpark. There are a lot of problems in the PySpark thing. So I need to check. I need to probably re-download the Cloudera distribution again, probably check what's going wrong and start working on it. Okay, so that's the reason why we couldn't really work on PySpark today. Okay, so yeah. Okay, so a quick recap of Scoop on the concepts you discussed. Sure. I think I'll do it in Notepad here. I'll be much more happier. Okay. So Scoop is more of a data ingestion tool, correct? So the very first example that we did was we tried to look at the different databases available inside a particular connection. So the very first code that we wrote was we said, hey Scoop, I want you to list, let's say, all the databases. So we're saying all the databases. To whom should I connect? So connect is basically an argument. You're passing a value saying, hey, in JDBC, then you have MySQL, then you have localhost. There in 3306, this particular guy is running. So he's the person that you need to fetch. So for you to log in into MySQL, this is the username, which was root, and this was the password, which was Cloudera. This is example number 1 that we saw. Example number 2 is a small changes. Instead of databases, you can also do tables. Okay, if I'm not wrong, it's called tables only. List tables, not data tables, plain tables. You need to specify the database also. So now you can say, hey, within the sample database, can you please list all the tables? Since it's a MySQL connection, you have the username and password that I'm providing for you. This is question number 2, the second example that you can probably do. Number 3 is you can try importing something. Okay. Number 3 is you can try importing. Importing is the next thing that we did. We went and said, hey, I wanted to import by connecting to this MySQL. Okay. And what did you want to import? I wanted to import this particular database. Okay. So, and more specifically, this particular table called SAMP. So we said, hey, I want to import by connecting to MySQL this database called sample, and the table is supposed to be SAMP. This is the username, this is the password. So this is an example of MySQL to HDFS import right now. So this was a MySQL to HDFS import. Okay. So similarly, what you can also do is you can import all the tables right now by saying import all tables. The only difference is you don't have to specify which table it is because it's for all the tables. You just say import all the tables and you hit enter. He'll be able to import all the tables for us right now. So the Scoop will make sure that he's going to import all the tables here within HDFS. Right? So similarly, you can also specify while you're importing a particular table for me, you can save it in a specific directory. So you can tell him, hey, the target directory is somewhere here. The directory is /work or something. You can specify that the target directory is somewhere here. Okay, let me remove the serial number. Okay, so you can specify what is the target directory also. To that particular directory, he'll be able to save this particular file right now for us. Okay, so the next thing is while you're saving, I was able to notice that you're saving always binary files, right? You can see part M00, part M001. So these are all binary files, but you can also ask them to save it as a text file, which is one of the way of saving it. Or you can tell him, hey, why don't you save it probably as a, let's say, Avro file, right? You can specify Avro file. This is also another way you can save, or you can probably ask him to save it in the form of OCR or ORC, right? So ORC or even sequence file. So these are all the different types by which you can save the file in the same directory, right? This is also another case that we spoke about. And then this was what? This was MySQL to HDFS import. This was done, right? So these are all the different cases. Then what did we do? We said, how about the reverse fashion? How about exporting from HDFS to MySQL? So what did we do? We went to MySQL, we created the table, and then we went on to basically say, hey Scoop, right? So we went on to say, hey Scoop, I wanted to export by connecting to the database, that is JDBC colon MySQL, whatever it is. I wanted to export to this particular connection that you're making. And then you need to obviously specify the username, password and all. Okay, you're specifying the username, password. Of course, the table also, because in MySQL you would have created the table. So you can specify to which table that you need to export. You need to export what? Export from this particular directory. The directory could have been, let's say, somebody like work. All the files inside work will be exported right now. Any number of files is available now. Everybody will be pushed right now. So this is what? This is from HDFS to MySQL. You are exporting it. There's a reverse of it. You are exporting file from HDFS to MySQL. Okay, so this is one example that we did see, right? And even while importing and all, another point I also discussed was that you can specify which columns that he needs to retain. You can specify columns like A, B, C, and D alone needs to be retained. So you can do this also. Another point I wanted to add. This export we have done. The next export we did was MySQL to Hive export. How does MySQL to Hive export work? That was very simple. I don't think we used export there. It was more of an import. So we are saying import from this particular connection, this table, this username, this password, everything. That's okay. But now we are going to say it's a Hive import. I wanted to import it inside Hive right now. So this is called as Hive import here. We are importing it into Hive, by this particular command here. And what else did we see? Finally, we saw about evaluations, right? He was able to evaluate certain queries for us. So you can go back and say, hey Scoop, how about evaluating by connecting to this particular connection whose username passwords are all like this. I don't think you need to specify the table because table is given here in the query. So the query is going to be select star from whatever table you want. That's it. So you'll be able to run this particular query and he's evaluating and he's giving you the output. This is another one that we spoke about. And I think that's it. While importing all tables, we spoke about another argument called exclude tables, if I remember. Exclude tables. So you can tell them to exclude these tables and all. A, I don't want B, I don't want C. You can exclude these tables also, right? I think that's it. Looks like these are the different cases that we were discussing. Right? It's just that we didn't go by a particular order, right? So, but these are the different examples that we were discussing. So this example was basically, HDFS to MySQL, then MySQL to Hive, right? So this was that example where it's more like, a clockwise kind of a thing. Okay. So any questions otherwise? Are we good till here? All these concepts, is it okay? The recap also on this one? Okay, sure. I'll save it and I'll send it across. I think I have a separate file. I'll probably upload that particular file. Okay. So sorry guys if it had been a little boring class because you know it, right? It's more of a, I'm not a big data expert. I'm just a person who will make use of big data a little bit here and there. Okay. So what we'll do is for next week, we'll jump into Spark and we'll have a little bit of NLP also. And then finally over to Power BI. I think with those three topics, we'll be probably, closing our course here. So I think next week, I think we were supposed to close it by today, right? But next week is something that we'll just extend a little bit. So I think a little bit of NLP, a little bit of Spark here, and then Power BI. So the three topics we'll be crunching it in the next week. And with that, probably we'll come to an end of this course. So if there's any questions you guys have, any doubts, clarifications, any files that's missing, whatever it is, feel free to just let me know. Okay, in fact, I have some time now, right? Since you have closed it early. If there's any questions you have on modeling exercises, etc., please do let me know. We can discuss that now. Else, I think we can really call it a day. Okay. Any questions?
I have one question. See, we in yesterday's HDFS architecture, we discussed about these nodes and how this what is it? The second one, Yarn will be doing the resource management and everything. So we will not be doing actually on all those, right? Just that if you want to work on Hadoop, we need to be aware of. We need to have Linux knowledge, some
Exactly.
commands, and for Hive, we need to have some querying experience, right? Querying knowledge.
That's it. That's it. So
Okay,
typically
just want
what
to
will happen
understand how
is,
the requirement actually comes and how we will be implementing this actually. Can you please tell on that? Because when we are not working on the file system and allocation and all those, so how does it come? So we'll actually we'll be doing whatever you showed now, or
this will also usually be taken care by admins, because scoop is something that you don't need it. More like you want to transfer data from this area to another area. Mostly what these guys will do is, this admins, they will write all the scoop commands, everything, and they'll give you something called as a batch file. You just have to run it, that's all. So you just have to run the batch file, then it will start executing. All these Hadoop commands will start executing. Mostly the amount of Hadoop that we will use is like, it's all written. All the Hadoop commands are all written. So you just have to know which file to be invoked at what time. So say for an example, there is a query. Okay, so the query will be already written. It's already saved. You just have to go and hit enter. That's it. The query will run. You'll get the output. Then when you want to transfer it somewhere, there is another batch file. You hit enter, he will transfer it. So, typically that's how it works. And in my cases and all, I've worked on other big data things where I'm just leveraging those architectures. Say for an example, there is something called as a Flink. Okay. So what a Flink, not Flink, what is that? Not Flink, NiFi. There's something called NiFi. So NiFi is once again another big data component who will actually kind of take up your logs. They will parse it, they will aggregate it, etc. So that was typically taken care by a data engineer. Now what that guy will do is, he will push it into something called Kafka. Okay, it's more of another, once again, another streaming engine, big data thing. I was just using plain Python to read all those logs, etc., do the analytics on top of it. I feel like 90% of the cases, the plain analytics is what, plain Python is what you will be using. I don't think you'll require any of these big data stuffs mostly, because it would have been automated already, or you won't have much of a dependency on top of it. That's what I feel like. But Hive, at least, yes, some people might use on a day-to-day basis. We never know. Okay, but at least from my experience, I would say that not much of this is in fact required. It's all automated. You just have to know how these components will work. Or probably if you're more of a product engineer, you need to tell them that, hey, this is the design, this is the architecture we need to follow. So that level of product knowledge is something also you might want to gather, which this examples might probably help you, to think on how we can make use of all these components here. Okay. And the first question that you asked me, all those things are more of configurations. You don't have to do anything. In fact, I'm not sure where we can find it, but if you go to this Hadoop and all, right, they would have configured it already. So say for an example, pom.xml. Let's search for that. Okay, if we get this file, okay, cool, superb. Okay, so this is somebody's pom.xml. Okay, so typically what will happen is there'll be these kinds of XML files and all, which will have all the configurations. So typically the work of a admin is to go into these XML files and he will pull out and he'll do all your configurations actually. So for yarn and all, I'll just check if there's anything that I'm able to connect to. Feature, okay, launch this XML POM. Actually, it's all pom.xml only. I need to search which one. Or shall we search for HDFS? So as you saw, right, those are XML files. Typically, these guys will download it and they will go back and configure. I think I can give you a different example. So if you go to the desktop, I downloaded Scoop today. I was just trying something. Where did I save this guy? I've saved it somewhere here. Scoop. So here you can see you'll have bin. Okay, so within this you can see, right? So all these configurations will be there. So typically the work of your Hadoop guys are they'll go back and change all these configurations and all. So they will fix, like you can see how many, nodes to use or how many these things to use. So this guy, these guys here, they will go back and change all your configurations, everything for you. So really, you don't have to take up the pains of doing all these things. You can leave it to the Hadoop people to do it. So once again, another configuration. There's an XML file. You can just come down here. There'll be some configurations that these guys might have kept here, right? So here there's another XML file, right? So you can see Scoop Metastore server port 1600. So these are all configurations already available. So you don't have to take the pains of doing all the configurations. It is typically taken care by a admin guy. He will do it for you. Okay, so the scripts, everything. So they will know it better rather than us. Okay, now you can see here common dependencies for Scoop. HBase using 0.95. So these are all the configurations required to work with HBase. So this is accumulo something. Okay, so that was your first half of your question. You don't need to, really deep dive there. Just understand what they are doing. That's it. Your work is done. It's all typically taken care by your, admin guys. Okay. Okay. So your next question is, can I provide some tips on how big data has been processed using cloud environments like AWS? Okay. Actually, Manoj, so the point is here you're opening a system, right? So this is a virtual system that you opened here. You have launched it here. Now the only difference is you're going to open a system which is sitting in AWS. That is, you'll be using PuTTY and WinSCP. That's it. So using PuTTY, you'll open your system. You'll execute all the commands. So PuTTY will be your command line. Using WinSCP, you'll transfer all the files. Otherwise, it's all the same thing. Even if you go back and write a Scoop code, right? So till now we were writing Scoop code and all. In Scoop code and all, we were giving the path. So we said localhost. Instead of it, if it were running in AWS, you'll just say, hey, it's MS SQL AWS running at 102-168-1:1. This is the port 3306. That's all. So the only difference is it's a computer sitting online. Okay, so I can't take a system with all these things right now. Since you've asked me, on the AWS part, I really can't go back and create a system. But generally just telling you there's not much of a difference. So the process is perfectly the same, exactly. So it's like you're opening a virtual system here, but there what you'll do is you'll use PuTTY. That's it. Using PuTTY, you'll open the system, or by using, let's say, WinSCP, you'll open and you transfer the file. PuTTY is your command line. All these commands, you're going to write it in that command line. That's all. If you have a Ubuntu system that you're buying from AWS, you can launch it using, this kind of VMware also. But typically, it's CentOS a system without a UI. Okay, they are CentOS system without UI. So mostly they'll give you without UI systems. So you really can't open anything. You can't get a UI, but all the files will be there. You just have to execute by giving all the codes, etc. That's it. It's the same thing, no changes at all. The only thing is you'll be dealing with URLs here. That's it. Great. Okay then. So I think we can probably call it a day, right? Okay. So thank you guys. Thanks for joining. Thanks for being so patient. And I should also say sorry for not being like too good at it. Unfortunately, yes, it's not my book of work. Okay. Thank you guys. Thanks for joining. Bye.